Hello friends, so today we are going to discuss another question on the Rn method. So this question is another tricky question, and in the last video we saw a mysterious 2 in the question. Now we have a mysterious 1 by n in this question. Now let me tell you how it's mysterious. So 1 by n can be written as n upon n square, and again we can multiply it 2, and then we can do it like this. Now if you notice, we have actually converted it into this form. So we can write limit n tending to infinity n plus 1 upon n square plus 1 square plus n plus 2 upon n square plus 2 square plus goes on to n plus n upon n square plus n square. Now if you take a n common from here, we have done it in previous video. We saw how to convert this form into the form which is required by us. So by taking a n out of this, we have n 1 plus 1 by n, and taking the n square common from the denominator, we have a 1 plus 1 by n whole square. Similarly, the next term can also be written in this form. So we have this in the next term, and this goes on to n taking common, we have a 2. We can actually write it as 1 plus n by n upon n square 1 plus n by n whole square. Actually our motive is to write, we know that these are cancelling, but our motive is to write it in the form that is necessary for us to solve the question. Now to solve this further, we know that this we can actually cancel the n and n square. Similarly, n and n square, n and 2. So now what we have is 1 by n, 1 plus 1 by n, 1 by n. So you can see that here we have an r by n, 2 by n, so r by n, 2 by n, r by n by n, r by n. So we can write it as r by n upon 1 plus r by n whole square, where we have the summation and limit n tending to infinity, summation of r is equal to 0 to n, r is equal to 1 to n. So now we just need to convert it into the definite integration. So we have a 0 here and a 1 here. I have talked about these upper limits and the lower limits in many of my videos. You can watch the playlist that I have made on my channel for the definite integration. So now we have 1 by n. 1 by n is converted into dx, and 1 plus x, r by n is converted into x. So we have this. Now to solve this, we actually need to separate these terms out. So we have 0 to 1, 1 upon 1 plus x square dx plus x upon 1 plus the differentiation of integration of 1 plus x square dx. Now to solve this, we multiply by 2 and divide by 2, and then we are pretty much to the answer. We are very near to the answer. So we have 1 upon 1 plus x square is tan inverse x from 0 to 1 plus 1 by 2. Let us take it out. Let us keep it out of the integration. So we have 0 to 1. Now taking 1 plus x square as t, we have 2x dx is equals to dt, and we have 2x dx in the numerator. So we have a dt upon t. Now solving this, tan inverse x, putting the values, we have tan inverse 1, so we have a pi by 4 minus tan inverse 0, which is 0, so minus 0, plus half ln t. Now we need to change the limits of the t, because we have converted the x. The limits of 0 to 1 were given to us for the x, but we have converted this into t. So now we need to convert the limit as well. Now putting the lower limit in x, we can get that this is equals to t. Putting the lower limit as 0 in the x, we get 1 is equals to the lower limit of t, and now putting 1 as the lower limit, as the upper limit, we have 1, this is 2, so now the upper limit gets 2. So now we have also changed the limit. Now we have half ln 2 minus ln 1. ln 1 is 0, so we have the answer as pi by 4 plus half ln 2. This is the answer. Thanks for watching.